Hey, this is Andy Sutherland, Skateboard Pendulums, here to show you how to make one of these pendulum motors. So let's get started. Um, on this video, in the links below, you'll find all the links for these parts. It's at All Electronics. You can get them probably for under $5. If you want to get a bunch of them, it's cheaper. Um, but that's about all you need right there. Uh, Just so check out those links and we'll get started here. I'm over taping or overdubbing this video from when I first did it because the sound just sucked. So let's see if this works better. And so let's get started. What I did in this video is I drew out the diagram of how you're going to spread the wires on the little board. It's one of these solderable PCB breadboards that you all have holes and you can just solder into it. I don't really use those. I just sort of solder the pieces together and use the board to sort of hold the parts in place. Uh, very, very bare bones and get her done type stuff. But it works. As you can see on some of my Instagram stuff that I've done, these things work pretty well. And let's see, what am I doing here? I am orienting the board. This is usually how I like to set it up. That's actually part of a bigger board, and I just sort of broke it in half because you don't really need that much room for these parts. So the first piece I put in here is the 1 farad uh, capacitor that sort of they call it a memory capacitor, so it sort of holds like a little charge. So when the transistors let the current flow, this thing will fire a little bit more of a pop than the battery can supply. Uh, yeah, I've just found it works better with these things through trial and error, and a lot of other people on YouTube that have set up these pulse motors. One guy to check out if you're into the electronics, you want to get into it, is Lid Motor. He does a lot of pulse motors and things like that. I just sort of adapted some of his stuff that he collaborated with other people, and this one just seemed to stick and work the best for what I was trying to do. And I just wanted to learn electronics and just sort of got sidetracked with pendulums for some reason. And once I found toy boarders, I sort of went nuts with the skateboarding and surfing and all the other fun stuff. So here, I'm sort of just going to draw it out and I write out everything. So that's the 1 farad cap. The capacitor on it has a minus side, so it's pretty obvious which side you're going to stick it in. The other thing is the little legs that come off of it. The positive one is longer. The transistors all have the same shape, but they're actually two different types of transistors. One's a PNP, and the other one's an NPN. And if you want to look those up, feel free to figure them out. But you're just trying to get this thing to run, doesn't really matter. Just make sure you put a PNP in the position I show you. And each of these transistors have 3 legs. So in this orientation, that left leg goes to the positive side. And then the middle leg of the PNP, what do I do here? Yeah, the middle leg goes to the negative side through the 15K resistor. And the last leg connects to another resistor and also from that into the other transistor, which is a NPN. So I'm going to draw it here. And the NPN also has 3 legs. So what you're going to see here is the, yeah, I had to look it up what it is. It's a 4401 NPN. And the rightmost leg there of the PNP goes to the 200 ohm resistor, and that connects to the middle leg. Now the rightmost leg of the NPN goes directly to the negative. And then the leftmost leg of the NPN connects to a couple of things, which you'll see here. Middle leg of the PNP also connects to the 100 UF capacitor, which sits there with a negative closer to the PNP, or on the PNP transistor side. And that one I'm showing here also has a little negative stripe on it, and then the difference in length of leg. So you want the shorter leg back towards the connection to the PNP middle leg. And then the leftmost leg of the NPN connects to the positive of the 100 UF capacitor. And here we have a LED, and I don't know why, but it just seems to work better with this LED. I still don't fully understand how this thing works, but basically you put the long end of the LED, they come with long and short ends. The long end connects, as shown there, to the NPN and the 100 UF capacitor, and the short leg goes back to positive. And then extending that even further, the coil, the little thing that gets the electric current to make a magnetic field to push the magnet, that is connected to the positive connector, and also then the lead coming off of the 100 UF, the NPN, and the LED. Seems really complicated, but it's pretty straightforward once you start to see it get soldered together. So here I'm just laying out all the little pieces. And voila. I did find some, someone online had this ink. Apparently you could draw lines on paper and make a circuit, and I tried it and it didn't work. I guess it had too much resistance. So here I'm going to start with the soldering iron. If you're going to do this, you're going to need a soldering iron of some sort. I found these butane ones work the best. No wires. It's about 20 bucks. Butane's $5. It lasts for a long time. I'm still in my first can. And fire that thing up, and it gets hot. And once it's hot, and you've been using it for a while, you should rub it on a sponge, because that cleans it and sort of makes the tip nice and fresh and shiny. They get crusty after a while with all the stuff in the solder. So I'm sort of going to build it the same way I drew it here. And we'll start off with the 1 farad cap. And we'll pop it in the holes there and get it in the holes there. Come on, Andy. There we go. And like I said, this is straight up just, I'm connecting wires here. I'm soldering wires together. I'm not soldering the the edges of the things into the board and then connecting the wires across. I'm just straight up just bending the wires and then connecting them with solder. It's very crude. It's not, it's very prototypish. But, if you want to get this thing to work, just get it done. There I'm putting in the PNP transistor, and I'm going to bend that leg back. Hopefully I zoom up here. I think I do. Can't really see what I'm doing, but I bend one over the other, and then I just basically lob some solder on it. And when you're looking at it upside down, it's sort of backwards, and I've screwed it up a couple times where, like, you think you're bending it the one way, but it's not the other. That's why I sort of drew this. So when you're looking at it underneath, it's sort of going to be a mirror image of what you see on the front. So here we start the soldering. Eventually, yes, here it comes. And so I'm going to just connect that positive lead to the leftmost PNP transistor. And I'm using a lead-free solder here. It's silver. It's a little bit more expensive. Uh, I just didn't want the lead around, so you can get what you want. Really don't need that much. That you can pick up at Radio Shack if there's still one around you. So let's see what did I do next? Okay, here I'm putting in the 15K transistor, and I sort of struggled with this as I remember doing it. Sort of put it on a diagonal like I did with the diagram there. Move your hands. Okay, there we go. And then it got all bent out of shape. I mean, another thing I want to mention while I'm doing this here is that if you're going to do this, you might also want to spend, $5 or $10. I don't know how much they are at Radio Shack, or you can order them online from All Electronics. Is a like a plastic. It's called a plastic breadboard. And what you can do is you can just model this entire circuit without having to do any soldering, and get it working and get it in the position you want it, so you understand sort of how it's going to plug together along with this video. And maybe I'll do a video on that later to see if anyone wants to see that. But that's probably the best way sort of to play around with it. Make sure you got it set up right, that it works, and then you can hit the solder. Uh, Here I'm stretching the leg of um, the negative end of the capacitor to the one end of the resistor. And my plan is when I do these is that I then take that one end of the resistor and run that all the way over. We'll bend that back and fold it over so it can reach the rightmost leg of the NPN transistor. Like you see in the diagram there, it goes across the top and then connects into that NPN. So I give it a lot of room um, to make it across. So I'm going to, I don't know what I'm going to do here. Okay, I'm going to clip the long end that's closest to the middle leg of the PNP and get it so that's short, but keep that long end, and I think I fold it over here. Okay. So now I'm going to put the NPN, and you have to spread the legs the way they come. They're a little straight down, and you sort of splay them a little bit. And I sort of stick that in, I think, one or two holes over to the right of the PNP. Push it in. And then start folding the legs into the positions I want. And like I said, I'm just sort of making connections here. There's no... initially I was soldering right at the base of each element and then soldering it across to another element. And I had some duds come out of that, I think because I soldered it too long and it fried the component. So I just decided I might as well just solder as far away from the component as possible, because these things are heat sensitive and the soldering iron's pretty damn hot. So here I'm just folding it over. Bending it. What the hell am I doing here? Looks like I'm going to solder again. And like I said, a lot of the soldering I did initially was with a your standard electric solder, and I cannot recommend, if you're going to do this, to get the propane, the butane soldering um, soldering iron. It just frees you up. You don't have that wire hanging around. I burnt my hand pretty bad on the electric one once, so uh, here we are, just hooking it up, folding it over, and then just connecting it. I can't really see which one. Okay, now I'm doing the. You can see where the hole is on the board. I'm doing the NPN um, to the negative. Getting that done. And then you trim off, the parts you're not going to extend over or connect or use to connect. You just tighten them down and make them short. Okay, I guess I was doing the 200 ohm in the middle. I think. Yeah, I remember this. The little arm I was telling you about, to make it from the rightmost NPN leg to the uh, that long arm from the 15K across was a little short, so I think I was just trying to hack in a little chunk of metal that I'd cut off from another part, trying to just sort of glue the whole thing together. Like I said, this is miniaturized caveman soldering and electronics here. This is not a soldering class or how to do anything, but you will get a pendulum to work out of this. So yeah, I farted around with this for a little bit. A little bit more than I thought. Damn. The other thing that's sort of upcoming is I through certain conversations with people who have looked at this, hooked me up with a company and some software to actually make a circuit board for this. So at that point, all you would have to do is just put the components in and solder them carefully right to the PCB board, and all the connections would be made for you. So you wouldn't have to do this folding and soldering and hack job type stuff like I'm doing right now. Um, so it will look a little bit more professional, and if there's interest, I might start making more of those. We'll just have to see if anyone else wants to do this, but we'll wait and see. So here I go, hooking up that negative connection to the NPN right leg. The big glob of solder. There we go. And yep, there it is. So now we'll probably move on to, let's see, I have the 200 in there, or the 15, so I'm probably going to do the 100 UF, or they're called millihenries. And again, the negative has to sort of connect to the PNP, and you can tell by the leg or the markings. So here I'm putting the 100 UF into the board still for a while. Can't really remember why I was going back and forth on this other than just trying to get it aligned correctly with the legs. And since I've started this, I taped this way back, and now it's already March, and I'm just finishing up this audio tonight. And I think I said earlier in the video about getting some professionally made boards. I got 10 of them, and they're working pretty good. The amount of soldering, but they came out really big, just because the way I drew it on the software I used. I don't know what I'm doing, so I went back and made another set, sent it off for, I think it's like $20. You can get these things made for 10 of them. So I should be getting a smaller one, but it probably wouldn't be as small as this. Since I've made this video, I've made some of these that are a quarter this size. So like every component's like touching, and may have gotten a little bit better at soldering. Here I'm putting in the LED with the short leg going back to the positive leg of the memory 1 farad capacitor. There, I got it in. Hold that back and fold that over the leg of the 100 UF and the NPN. So those 3 components all touch, and then I leave a leg. That leg is the one end that connects to the coil, and the positive leg of the 1 farad. I must have had it backwards. I don't know what I'm doing here. And then, the other leg of the positive, basically directly to the battery, connects to the other side of the coil. And that's how it sort of regulates and fires itself. The cool thing about this setup and this motor is that it works with a wide variety of pendulum lengths. And if you know anything or remember anything about pendulums, is the longer the arm of the pendulum, the longer the swing, the duration of the swing going past midpoint. So this circuit will compensate and push at one that's 30 inches long, as much as one of the small little 4-inch long pendulums that you've seen maybe on some of the Boundless Brooklyn half pipes I've made since I've started this video. But those have a really short swing, and this same motor, same battery, everything's the same, will pump that, and will also pump a 30-inch pendulum. Now you can mess around with different size magnets. You can make it a 3-volt with a two AA batteries. That gives it a little bit more power, but there's a lot of different things to play around with this thing. For some reason I just find it interesting. I really don't know why, but maybe someone else does. So that's the purpose of the video, is if you want to make this. So here I have it together, and I'm basically showing you the top, and it sort of matches actually pretty well to the drawing. And so now what I do is I hook up a coil. That's a Type 66 coil, or bobbin. You can get at any Michaels or any sewing place. They work the best. I just, out of the other bobbins I've tried. And it comes down to the amount of wire you're putting in there. I mean, there's so much more experimentation that you could come up with to try different things to see what's optimal. I don't know. This is sort of trial and error here. I landed on this setup and then got into making things with it. So there's probably more tuning with this motor than I've done. That's possible. So here I hook it up and I grab. I'm hooking up the negative. And the thing is, it won't start blinking until you get the two ends of the coil connected. That completes the circuit. But since I already did that, I think this will just start blinking. There it is. It's blinking. And what you'll see is the magnet will can change the frequency of that blinking. It blinks at a standard rate with nothing, but then when the magnet goes over it, it changes and it'll give it a little kick. There is a polarity to this. There's a preferred side. You can see it give it a little kick there. Now everything's loose, so it's not really moving well. When you tie all these things down, they get they perform better. But that gives you, I'm giving them a swing. But you can see some activity there, and that's about it. Just get them going. And then I also show this polarity with with just an actual magnet here. You'll see I put a magnet on it, and it will just sit there. It moves a little bit. And then if I flip it over, it will pop it right off. Boop. And I still haven't quite determined which way is better, whether it's the pop or on the other side. When everything's locked down, it sort of shuffles it to the side. It doesn't bounce it up. And there's some beer. Enjoy.